Hello, my name is Doshi Donald, and today we are here to prove that the OLS is blue. The OLS simply means ordinal square. So we are starting with the unbiased. So we are here to show that what the beta 0 and beta 1 is what unbiased. So let's start with the proof. Now we know that beta 1 is what S subscript xy over what s xx, and we all know that this is this. Are we okay? So let's continue, and this can simply be written as what this. Are you getting it? So let's continue. So now from here we can let this be equal to what our w what I from here. Are you getting it? So that means the whole of this can be written as what beta 1 equal to what summation of w I y what I. Are you getting it? So we also know that what our yi is equal to what beta 0 plus what beta 1 multiplied by si plus the small error. Are you okay? So now we are just going to expand the bracket. Are you getting it? So we are going to multiply through by what summation of what wi. Are you okay? So we use this to multiply this, we are getting this. We use this to multiply this, we are getting this. We use this to multiply this, we are getting this. Are you okay? So now there's some basic terms that we have to know. Are you getting it? That the summation of wi will give us what 0, and then summation of what wi square will give us this, and then the summation of what wixi will give us 1. This simply means that what our summation of wi si is equal to 1. We can prove this. We know that what our summation of wi is what summation of si all over what summation of what s square I. Are you getting it? So multiply by the same si, which will give us what summation of what s square I all over what summation of si square. So s square, so it will cancel, so it will give us 1. That's why we are getting 1. So now after doing all this, we are expected to do what? Take the expectation for what both sides. Are you getting it? That means you are going to take expectation of what this and this. Are you getting it? So when you take the expectation of what beta 1 equal to what the expectation of what beta 1 plus what summation of wi multiplied by the small error. Are you getting it? Now this is a constant, so you bring it out. So the expectation will only affect this. So here it is. So now from here we know that what our summation of wi will give us what 0, and this will give us 0. So this 0 multiplied by 0, we are getting 0, and it will be left with what beta what 1. So surely here we can state that our expectation of what beta 1 is equal to what the true beta what 1. Are you getting it? So now we are done with this. We are moving to what the beta naught. Now from the beginning we also know that our beta naught cap is equal to what y cap minus what beta 1 cap, and what the mean of s. These are the all mean of y, mean of s. I getting it? And we know that what the mean of y can be written as what yi all over n. Are you getting it? Minus, and we know from the beginning that this will give us what wi yi. I getting it? Summation of the, so we just brought the what summation sign outside. Are you getting it? So here too we can make what we can bring the yi outside. Are you okay? So from here our yi outside left with this. Are you getting it? So from here we also know that this will give us what beta 0 plus what beta 1 si plus what our small error. Are you okay? And we know that this is a constant. Are you okay? So still we take what the expectation on both sides. So expectation of this equal to what we are writing this because it's a constant, so it will multiply. So expectation of this multiply by what? This. This is a constant, this is a constant, so we take the expectation of this, which we know from the beginning is that what? The expectation of the small error give us what? 0. So from here, look at what you are to do here. You are writing this here. Now, looking at this, we just multiply this by what? N, and we divide by n. We know there's no change when you do this, because this will cancel this and it will still be 1. Are you getting it? So what you are now to do is what? We are going to expand this. So we are going to multiply this by this. So this will multiply this, this will multiply this, this will multiply this, and this will multiply this. And we are getting this. Are you getting it? Because of the summation sign here. Are you getting it? So this simple means summation of what? Beta 0 all over what? N. And we know that what? Summation of beta naught is simple what? N multiplied by what? Beta 0. Are you getting it? So from here, this will give us what? Beta n multiplied by what? Beta 0 all over what? N, which will cancel out to become what? Beta 0. So here we come. So let's continue the same. So this will still give us n. So n multiplied by this, it will cancel out, and this will give us what? X, the mean of x. This will give us the mean of f, and this will cancel this out. So it's left with beta 1, and then the mean of s minus. So we are still writing this, and then the summation sign will only affect what? The non-constant wi here. Are you getting it? Then minus. We are bringing only what? The n. This will give us the n multiplied by this, which will still cancel out, so it will become 1. So it will be left with this. So here it is. So our beta 0 here, our this here, plus we know from the beginning that this will give us what? Summation of what? wi will give us 0. So the whole of this will become what? 0. Are you getting it? We also know that this from the beginning will give us what? 1. Are you getting it? This, and then I prove this over here. Give us 1. Now from here we can continue our beta 0 plus on this, because this is 1, it will be left with this minus sign. So when you subtract this from this, we are getting what? 0. Are you okay? So it will be left with a beta 0 plus 0, which will give us what? Beta 0. Are you getting? So truly you can also state that what? Our expectation of what? Beta naught half will give us what? Our beta, our true beta 0. So this is the proof for what? The unbiased. So my next video I'll be treating linear. Thanks for watching.